Well, thank you for the introduction. Sorry, my name is Guido Oswald. I work for SDS, so not too independent, but I try to be. And I will talk a little bit about big data analytics and analytics 3.0. So the first buzzword in the title is big data. And I'm trying not to talk too much about big data. I mean, we heard all about it, I think, in the meantime. The 3 V's, volume, velocity, variety. And to be very honest, I think this is a little bit overhyped at the moment, so, excuse me. So I can't hear it anymore. I mean, there is a lot of hype around big data. The good thing is, according to Gartner, about the hype cycle of Gartner, and it's already on the downturn, so we might not see the term big data too much, although the thing will stay, right? We'll have more and more data, and it will get faster and faster. But let's talk a little bit about the other buzzwords, analytics 3.0. Not so much talked about, but I think it can be a game changer, even more than big data will be. So what is analytics 3.0? I think the term got created by Tom Davenport, and he is describing a lot of what analytics 3.0 is in his book, Keeping Up with the Quants. Although I think he's not using the term analytics 3.0 in the book. I think the term came afterwards. So there's a quote from him, not in the book. He says, analytics 3.0 will really affect all industries, all sizes. So from this, very important, it's not only big enterprises that can do big data. Right? So there's a very, very interesting conclusion from him here. There will be a lot more companies and a lot more people involved in analytics 3.0. So what is analytics 3.0? Let's have a look. So analytics 1.0 basically is what we did all the time. Basic standard reporting, this is what SAS is doing for almost 40 years now. Right? So you have usually small data sets. You do descriptive statistics, usually you look in the past. You create nice pie charts, bar charts from it. Dashboards we all seen and do already. Okay, again, this took like 50 years, and then there came big data. Big data now is a very different way of dealing with not only big data sizes, but different structured data and a lot faster data. The big ones, Google and Yahoo, showed how that is possible. They invented their own technology actually to keep up. So traditional data warehouses or technologies will not be able to cope with this amount and speed of data. So Google invented the Google file system, MapReduce, big tables. Yahoo took the concept, created Hadoop out of it, which is very well known, and I think Hadoop can be the next Linux in the data centers. It's an open source framework to handle large amounts of data on very cheap hardware, basically. Well, this all came up with, about mid-2005, 2006, that's that area. But firstly, big data was only done by the big ones, to be very honest, right? The Googles, Yahoo's, big enterprises, not a lot of smaller companies are actually dealing. And same here, right? When I talk to customers, to our customers here in Switzerland, many of them said, well, we don't have big data. Don't talk to me that yet now. We don't have this big data. Which was, or is still true maybe. But we see a trend now, and this is basically what Analytics 3.0 is all about, that these two emerge. Right? We still do the old way, we still do it over dashboards, they're very important and a good thing to do. We don't throw away our data warehouses or data marts, but big data is now joining in, and we combine them. Though there's several trends going on with Analytics 3.0. First of all, of course, is the integration of big data and the traditional data warehouse or data dashboard-based descriptive analytics. Second trend that we see is we're moving a little bit more from only doing descriptive statistics to doing more predictive and even prescriptive statistics. So descriptive, again, is analytics that I look back. I look at my history, do a nice line chart, bar chart out of it. That is descriptive statistics. Many people call it BI, business intelligence. For reporting, I call it mostly. Most of the time I call it reporting. Predictive actually looks forward, and prescriptive even helps you do decisions. And that's what it's all about, right? You help doing decisions. If you plot the degree of intelligence on the x-axis and the value or the competitive advantage on the y-axis, you could say this is basically your analytics 1.0. You have got your raw data, you clean it a little bit up, you start reporting. Maybe you do some ad hoc reporting and even alerting, but that's about it for the classical way we used to do data. And again, this was mostly small data, also you wouldn't have called it small data before big data came around. And now what we see is the trend that actually we are moving upwards in the trend. So we do forecasting, and we saw a nice example how that evolved in the keynote this morning. What we'll have next, and the highest level actually is optimization, right? So we optimize our inventory. We optimize the way we deliver stuff or our products or the prices, whatever. And there is, as the y-axis suggests, a lot of value in there. So many companies figure out, wow, we can save a lot of money or we can do a lot of more money by doing this. If you go and look at the decision, in the end you're doing decisions, right? So how, the human intervention that is still needed for to do decisions with descriptive statistics, obviously you had a lot of human input to do that. And funny thing, in the keynote this morning about the econometrics, we saw this, right? There was a lot of human input. And now they switched to reducing this more and more. The diagnostic is basically why did it happen, so you have one less piece that you need to estimate. It's done by the system for you. Predictive actually looks into the future, does the real forecast. Though you only need to figure out what you will do about it. And then this is what we call enterprise decision management, or what's often called enterprise decision management. The system will even help you find your decision or suggests something to do. For strategic decisions, it's a bad idea to automate that. So you wouldn't automate strategic decisions. This is something you probably would still do manually, and there's only a few of them, so that's quite okay. But there's also something, or some places where you actually want to automate this. And there's lots of examples, right? Your credit card, if you put your credit card in a machine, the system, the ATM has to decide in seconds if there's a fraudulent transaction or not. If it does decide afterwards, you already have your money. So the thief is gone. And there's many, many more examples that where this decision actually needs to be automated and it needs to be really quick. And this is Analytics 3.0, combining a lot of data. I mean, look at the big credit cards company, they have millions of customers. And they keep using their credit cards worldwide on ATM machines. So there's a huge amount of data coming in very, very fast, and you need to automate decisions really, really quickly. And we're going away here as well from the simple business rules thing, though, just deciding, wow, this is a credit card used in New York, and a second later in Tokyo. There's this amount of kilometers between these two places, so it's probably wrong. A simple business rule, you don't even no need to do a model there. But we're going away from that and even execute analytical models in real time to do these decisions now. And this is possible now with the latest technology. Okay, so another trend we see besides this enterprise decision management is democratization of analytics. Democratization of analytics means a lot more people in your organization will use analytics, or actually all three kinds of analytics, to do decisions. So usually, if you look at the past, I don't know, C-level might have used these reports generated by them, analysts in the back, in a small backdoor back room, and they use these nice reports to do their strategic decisions. Now this is moving into the field, and this is something we strongly see at the moment happening. And technology actually supports it now, because everything got so much faster and so much easier to use that this is possible. If you look to the analysts, Forrester, for example, calls this now agile BI, agile business intelligence. It's a little bit not too analytics focused. It takes not into account analytics or forecasting and predictive analytics and prescriptive analytics. Gartner actually has a magic quadrant which takes that into account a little bit more. So since I'm completely independent, to show you that's what's possible, I took the leader here to show you that it's really working and how this could look like. So the tool at SAS is called SAS Visual Analytics, and it has different modules to actually deal with the raw data towards the end report that you can actually even show on iPad or iPhone anytime. Since the last version, it actually works on phone now, right? So same report that you build, but this is again more or less analytics or descriptive statistics, right? That we do here. This is reporting, what I could call reporting. Interesting piece actually is here. Visual Analytics Explorer allows you to walk very freely on massive amounts of data. And I will show you how that looks like. For a second, I need to switch my monitor, I think. Okay. Where's my mouse? Here we go. So this is Visual Analytics. You see it's all browser-based. It will be HTML5 soon. Currently it's the Flash. I make that, actually, let me do this a little bit. I make it bigger so we have a little more real estate. I have a demo, a data set here, a company called Insights Toys, producing a toy factory basically, having data about sales, where the sales went, what products, and some production information. And I have a lot of options to visualize this data. The good thing, my favorite visualization is called auto charting. Auto charting means actually the system even decides for me what I can, how to visualize that stuff. And let me just, I want to see how my sales developed over the past year. So I take, where's my years? So I have 34 years of sales information in my system, and I take my order total and just track it to the canvas, and he will decide how to visualize it. So currently he's doing a bar chart, so I see 2011 was probably my best year yet, but I can sort this over time, so we can see how I did over time. Expand this a little. But this is how we did over time, and I could even decide, well, okay, bar chart might not fit. I want actually a line chart. So let's select the line chart, and this is how I did over time. And this is still descriptive, very descriptive statistics, nothing very, very interesting here. I could add, I don't know, my marketing cost. I could add my product cost maybe. On this chart, I actually can do it in one, excuse me, share access, so I could do it in one chart, but there's nothing yet to what I would call real analytics. But these systems, again, are capable of doing the same thing, and I can show you, if you have the time, to do the same thing with, this is currently running on my laptop, so it has 2 small cores. It's not the very fastest thing, but I can show you the same thing on a data set that has 1 billion rows. Billion with a B, there's a lot of zeros behind it. Not really fancy because it's just summing, but look at that. I can, with one click, I can do a forecast now. And this is not forecasting in terms of I just keep drawing the line. This is a real forecasting. So the system actually evaluates 6 different forecast algorithms and takes the best, chooses the best for me. And you see this is, in terms of democratization of analytics, this is something a business user can use. This is yearly, the forecast is not very, very nice looking, right? The very broad confidence interval as well. Let's go and do it monthly. Where do I have the monthly? Here we go. So I just replace the year with the month, and now he's doing it the same thing, and look how amazingly fast it is. He's evaluating 6 different forecast algorithms and chooses the best for me. I might actually extend this to 18 months. because they have a toy factory, and if you look at the forecast a little bit more closely, you can see that we have a peak every December. Makes sense, right? We have a toy company. But we sell a lot more in December. So this is the real forecast. If you want to know more details, actually you can see it. For example, the order total was forecast using the Winters method, additive. Right? So we have a seasonality in here, and we have a general upward trend. But as a business user, I don't even know what that means. I don't, and I won't. I don't need to. I can do my forecasting now on my own. Okay, so this is nice. We can do forecasting, but now remove these two, and let's do a little bit more advanced. We not only want to forecast our order total, we want to build or to see what influences it and how it behaves differently if we change the underlying factors. So I see that I can add underlying factors in here. So what influences my forecast? So my market penetration maybe, my marketing spending probably, and my customer satisfaction maybe. So I drop that here, and now he builds a model and improves the forecast. And you will see that my confidence interval actually got very, very small. So my forecast actually improved dramatically. It's demo data, and in real life it wouldn't properly improve that dramatically. But you can see because it's grey out, my market penetration actually doesn't even influence my forecast. So he left it out, not even using it. Okay? And not only that, I build a better model now, a better forecast, I can do a scenario analysis. Scenario analysis means I can go in two directions. Actually, I might change this to shared, to a separate axis, to a little bit more closely. I do a scenario analysis, which means I can do in both directions, right? So first direction would be, what happens if I increase my marketing spending in January and February, yeah? Or what happens if I do increase my marketing spending for, I don't know, 20% all the time. Yeah? So I draw a new line here, and if I click on apply, it actually recalculates and creates a new forecast. So up there you see the gray line was my original forecast, and the new blue line actually shows me the new forecast with the new marketing spending I evaluated. And the same thing goes the other way around. Yeah? What do I need to do to, I don't know, have a peak here in July? I want to have a peak in July. What do I need to do to have this amount of sales? And you see, it's easy. I just need to improve my customer satisfaction to 12,000%. Easy as it goes, right? So a little bit difficult. Let's go back. So in these cases, usually would say bounce. So I bound my customer satisfaction to maximum 100%. And I would probably say that is impossible, so I might actually lower that more down. Or better way, if I don't even think that I can influence customer satisfaction at all really good, I can leave it out. And then if I now do the same thing, he will only use my marketing spending, and you see this is the marketing spending that I need to do to reach this amount of sales. Well, that was a very, very quick, I think we're running out of time already, a very, very quick introduction how democratization of analytics can look like. So we're running into a new era in terms of analytics, where a lot of more people will use these tools to do things normally only a few people would have been able to do in very dark rooms in the back alley. So this is something that will change companies and change corporate culture in the future, I'm very sure. And we run out of time, but there's even more stuff, because now I'm even able to create models. I can create a model. I have a different data set here about a retailer producing or selling foods, and his organics purchase. And I can do, for example, if I want to build a model, how can I predict if somebody purchased my organics products? I can do a logistics regression, and just by drag and drop, I do that as a target variable and choose a couple of values that I would think might influence. This is my target variable. That I would think should influence the organics purchase in this case. And what he's now doing is he's building a logistics regression. It's all an in-memory engine. Again, it's learning on my two cores, and we don't have time to. But if everybody's interested, we have a boost down there, so I can show you the same thing with 1 billion rows, right? So 1 billion real data. We have 1,000 cores back in Carrier in our headquarters to do the same thing. And this is something, again, a business user can do. He can just build a model, right? He's showing me the variable influence, so a couple of variables that he did use, p-value is very, very high, so it's not used. I can see it's a residual plot, and if I select some of the outliers here, I can see what their influence is, so they have a lot of influence, obviously, in the model. I can see my lift chart, my rock chart, or the misclassification rate of that model. I can compare models. I can not only do logistics regression, of course, I can do linear regressions, decision trees, clustering, generalized linear models, and I can compare them, and so on and so on. And I can export the scoring code to be used further on. Right? So by the quants, the quantitative analysts, maybe they would use this and further enhance it with different tools. So I hope you got a small glimpse on how what's possible now, and I think we'll run out of time, so we don't have time for questions. So thank you very much.
Thank you very much. Time for one short question.
Oh, we have time.
And a short answer.
I'm trying.
Who has a question? Yeah.
It seems remarkably easy to use the tool, to ask questions, to look at variations, impacts, make projections, and the system response time is very fast. Such a tool that's easy to use may be harder to ensure that any of the results are correct at all. That is, whether the model they chose is correct, whether the parameters, the tuning, the raw data, all of those things. So how does, when you just click and point, like you did with the camera, how do you make sure that the picture actually captures something that is true in fact?
That's a good question. And to be very honest with these models, if you build a model, this is something you would probably hand off to somebody else to improve it and to verify it even. There's, of course, SAS. This is what SAS is doing for 40 years almost now. But we have different tools that are much more complex, but they are not to be used by business users, right? This is a tool especially targeted for business users. So I'm a business user and having no idea how a model, how a logistics regression really works, can do it. And it's the first shot. And actually, I think for smaller companies who don't have the possibilities, it's better than nothing, right? Because they
that sounds perfectly sensible. I have a company that does data curation and large scale information innovation, and we find that 80% of our customers don't even ask us what an error bar is. They don't even ask us what an error bar is.
Okay.
So you say, well, should we give them the error bars? Well, let's see if they ask. And they trust what comes out of these fancy machines 100%.
Yeah, I mean, there's obviously a very deep discussion ongoing about where this one slide I had with human interaction. It's a very bad idea to really trust everything 100%. I think there's a learning process going on. Analytics, again, we're just starting with analytics really, right? This is now the era that starts. And I believe there is a phase now that everybody has to learn how to deal with these new kinds of tools and don't trust everything that's out there. Try to validate how to validate this in the future. And this is a process that needs to go on. And remember that these business users are using the target audience for these kind of tools. They didn't use it before, so they need to learn how to interpret these as well. So, yeah.
Probably we have to teach the students much more.
That's why we're here.
Particularly if we deal with numbers, because too many people just adore numbers. I mean, without any question.
Yeah, but numbers don't lie.
That's true.
People lie.
Okay, thank you very much again for the nice.